Hello, everyone. My name is David Beiruzzi, and I'm a senior software engineer on the Amazon Cognito Service team. I'm joined today by Daniel Lees, and he's a principal architect at the bank HSBC's Cloud Services division. We're presenting today on security and compliance for modern serverless applications. A quick agenda. As application builders, it's important to understand what services are available to use as building blocks to help. So I'll start by introducing you to some of the services in the AWS portfolio that were built specifically for use cases around security and compliance. Then I'll talk about security and compliance best practices and strategies using the following three themes. Protecting the front door, making sure that all the requests that you let in are the ones that you want in. Securing your resources so that even if you have code bugs or misbehaving clients or bad actors trying to hit your endpoint, you put the necessary guardrails on your resources, and no matter what happens, your resources remain secure. And then keeping a paper trail so you always know who did what to what resource for compliance. Then I'll hand it over to Daniel, and he's going to talk about an architecture that he's built at HSBC to monitor and enforce compliance in their infrastructure. End user identity is extremely important, and it's important to get it right. End user identity is really the front door to most of your applications today. It's by issuing tokens against your end users, you can use those to secure and grant access to your backend and resources. By owning your own identities, you can put profile information in and track various things about your customer, which you can then use to customize their user experience when they hit your site or your app. And it's really your avenue that you can establish a relationship with your customer, so you can reach out to them via push notifications or email channels. But doing this yourself is hard. And if you're building your own username password database, it can be catastrophic if you get something wrong, not only for your end users, but for your company. So you need to put security first, and you also need to consider minimizing user friction. Nobody likes an authentication experience with a whole bunch of CAPTCHAs or having to re-authenticate every hour. And so you really want to respect your end user and not put an overly burdensome experience in front of them. And then your auth solution needs to be available and ready to scale at a moment's notice when your app takes off. Which is why we created Amazon Cognito. So Amazon Cognito is a managed user directory that lives in the cloud. There's no servers to manage, and we'll issue standard OpenID Connect tokens that you can use to authenticate against your backend. We support username and password sign-up, but to make it easier for your end users to sign in, we offer various social integrations, Facebook, Google, Amazon, as well as corporate federation. If you have your users in an Active Directory or some OpenID Connect-based solution, you can federate them in for an easier sign-in experience. We offer a customized hosted UI, so you can integrate with your app with a few lines of code. And then we also offer full-blown SDKs if you need to customize your authentication experience. So you want to put custom challenges in your auth-flow, or you want to do something like a one-time code to log in. So every time they log in, you send a code to their phone, and they can log in with that code. You can do that with our SDKs. It gives you the ability to get AWS credentials and do access control directly from your mobile app, so you can talk to S3 or Dynamo. And it's standards-based, so we implement the OpenID Connect standard and OAuth 2 so that you can interact with other companies and easily use third-party libraries to validate your tokens. There's a couple of scenarios that we support. The first one is the mobile app. You want to authenticate your users, you're writing a mobile app, and you want to secure access to your backend. We have the business-to-business scenario, and this is if you imagine you're making a travel booking app that you want to sell to multiple businesses, and they want to authenticate their end users, their employees, against their corporate directory so that they can book travel in your app. Then there's the business-to-employee use case where You might have kind of a time-off reporting app that you have in your corporate internet, and you want to extend that to the mobile app so that people can report time off from home. The employee can authenticate with Active Directory, get tokens that you can then use against your serverless backend. There's service-to-service integrations where you have some service that needs to make a call to another service, and you need credentials to do that. And then there's IoT scenarios where you have IoT devices that need to communicate with AWS's IoT core functionality. There's two real serverless architectures out there. The first one, and lesser prevalent, but it suits some people's needs, is when you have an app that's talking directly to AWS Web Services. So if you have an app that's talking directly to S3 or directly to Dynamo with no backend, it supports kind of a limited set of use cases, maybe a photo sharing app or something like that, but it's truly the simplest integration. But then there's kind of this more popular integration where you get credentials with Cognito, and then you put API Gateway in front of your backend. Your backend could be running on EC2, or it could be Lambda functions, and you proxy all the requests to AWS Web Services. Instead of building all the business logic into your app, then you can kind of abstract that behind your API Gateway endpoints and quickly change things on the fly without having to re-release your app. So Cognito is really two services. I have this Venn diagram here to show you how they're unique and how they overlap. So user pools is our standalone identity provider for issuing OpenID Connect tokens. And then federated identity is if you've authenticated somewhere else and you need AWS credentials so that you can access AWS services directly. There's a little bit of overlap between the two. They both support federation through social providers, and if you want to integrate with SAML, with Active Directory, they both support that. And I've found that kind of the easiest way to explain when to use one or the other is in terms of what you have and what you want. So you want to use Amazon Cognito user pools if you have end users who want to sign up and sign in, or they want to federate in with an existing social account. And what you want is that secure, managed user directory that supports authentication. We have profiles that you can customize, store what you want about your end user. We have that hosted UI that gives you a quick getting started experience if you want industry standard OpenID Connect tokens or OAuth 2, or you want to act as a SAML 2 service provider, and you want tight integration with API Gateway. So you can take those Cognito user pool tokens directly against API Gateway, see all the user profile information and the username directly in your backend. You want to use Cognito identity pools if you're trying to get AWS credentials. So if you have a user that's authenticated elsewhere, or you have guest users that are just kicking the tires of your app, we allow you to exchange the token that you bring in for AWS credentials. It will give you a consistent identity for each of your users. And by consistent identity, I mean that if they've authenticated with Facebook or they want to link their Google account, they can be the same identity. We give you those scope time-bound AWS credentials against each of those identities. You can talk directly from your mobile app to AWS services. And if you have kind of use cases where you have multiple classes of users, you might have admin users, and you might have regular users or paid users, and you want to map them into different roles based on what they have access to, you can do role mapping based on the claims in the token. So you can say if they're in the admin group, map them into this admin role. So you can do that for authorization. So you can use those two services standalone, or you can use them together, and I'll talk you through how you might do that. So if you have a mobile app and you want to authenticate your user, you can talk directly to Cognito user pools. If they're federating in, we may redirect them to that social provider or that Active Directory to authenticate. And when that provider returns a token back to us, we will copy the profile information into your profile and return Cognito user pools tokens. We'll refer to that as the cup token from this point forward. And with that cup token, you can talk directly to your serverless backend through API gateway, or you can take it to Cognito identity pools to exchange for those temporary AWS credentials, which you can then use to talk directly to something like DynamoDB or S3. So every application has a bit of configuration. And we have AWS Systems Manager Parameter Store to help you store that configuration. It's our place to store application parameters with a hierarchy. And you could kind of build that hierarchy based on your business needs. So if you want to separate your dev configuration from your production configuration or separate your configuration amongst applications, you can kind of do that with the hierarchy that it supports. If you need to access secrets, so if you have an RDS password that you want to use Secrets Manager to help you rotate and secure, you can reference from Parameter Store any of the secrets that you've defined in Secrets Manager. And it's a great way to kind of have all your configuration in one place. So you can use one client for the Systems Manager Parameter Store and not only access your application configuration, but you can also access your secrets. It's integrated with IAM to give you that fine-grained access control, not only to the individual parameter level, but also to branches of the hierarchical tree. So if you, in your Lambda execution role, you want to give access to the prod portion of this tree, you can put an IAM access control policy in your execution role to do that. It's hooked up to CloudWatch events, and you could use that to configure notifications when changes happen. So you might, if you change a particular configuration, you might want to take some action based on that. You can take those actions in Lambda functions. And it's a great way to share configuration across your Lambda functions. If you're putting your configuration environment variables, that kind of scopes you to that individual function. So if you want to share things across functions and put them in a nice central location so that you can easily change them and not have to worry about going into every single function and changing it on the edge nodes, you can put it there and easily centralize it. Next up is AWS WAF, and that's kind of our firewall to protect you against common exploits on the web. You can think of it as a proxy that sits between your endpoint and the web. And you can use it to kind of block malicious requests, meaning that you can put rate limits on particular IP addresses. You can filter things that look like cross-site scripting attacks. And you can also constrain requests. So if you have you don't want to let big files in, or you want to do something, you can put content length constraints on there. It's integrated with CloudWatch metrics, so you can see what's going on and visualize actively what's currently coming in, so that if a new attack comes in, you can figure out what it is, and you can quickly turn the knobs to protect against it. It has a bunch of rule groups provided by AWS and its partners that are kind of canned for protecting against things like DDoS, application attacks like cross-site scripting and bot attacks. And as of a couple of weeks ago, we announced a tight integration with API Gateway. So you don't have to do any kind of integration with CloudFront anymore. You can put it right in front of your API Gateway, and it's a great kind of firewall that you can put there and block things before they get in. So as your company grows and you start to have multiple accounts and lots of people working in the same account, you really need to understand kind of what the perimeter of your AWS resources are. And that's where we have AWS CloudTrail. So CloudTrail allows you to track all the user activity in your AWS account and see what people are doing. It's enabled by default, and you can see configuration change events. So if you're creating a Lambda function or you're modifying a WAF configuration or modifying WAF rules or something like that, you can see exactly who did that and what they did. You can also enable it for data events. So if you want to see every time somebody uploaded something to an S3 bucket or something like that, not just the creation of the bucket, but every single file in that bucket, you can do that. If you need, for compliance reasons, to kind of see this for longer term, you can persist it to S3 or other durable storages so that you can do some analysis on it later. Again, it's connected to CloudWatch events, so you can take action based on changes and use that to automate security enforcement. And it's good for operational troubleshooting. So you didn't make any code change, but your application starts throwing some errors, and you're not sure who did what. Instead of going to all your APIs and doing describes on them, you have kind of this central location where you can look at all the changes that recently happened, or you can try and correlate them and see what happened, and that may be the issue causing the errors in your application. Next up, we have AWS Config, and that's really our way to discover all your resources and relationships between those resources in your account, even the ones that have been deleted. Instead of calling those describe APIs in each of your services to figure out what you have, you can kind of view it in this normalized form. And you can track your changes. You can, again, connect that up to CloudWatch events so that you can, if a change is made, you can trigger an action. You can deliver those snapshots to durable storage like S3 for further analysis, and it has some integration with change management databases if that's how you prefer to ingest it. Here's a quick view of the console for AWS Config. Here we made a change to a Lambda function. We created it on April 6th, and then we made another change on August 1st. And you can see all the configuration details about our timeout, our memory settings, things like that. You can go through the version history and see exactly what's changed over time. So now let's start talking into some of the strategies and best practices around security and compliance. Before I start talking about protecting the front door, I want to quickly touch on the AWS Shared Security Model. I hope you've all heard of this. Basically, it tells you what AWS is responsible for securing and what you're responsible for securing. So AWS is responsible for the physical security of our data centers and the security of the container that runs your Lambda function, and also the runtime. But you are responsible for everything in that Lambda function. So anything that exists within the walls of that Lambda function, you're responsible for securing yourself. So the threats that can happen at the front door start with your end users. So end users like to keep things simple. They try and find the easiest way in and cut corners everywhere, so they might be using simple passwords, or they might be using the same password across multiple websites. There's the threat of long-lived credentials. So whenever you have credentials that are long-lived, there's the risk that over time you get a little careless with them, you check them into some code repository, or you put them somewhere where you actually don't want them, and somebody finds them, and then you can't revoke them. And then because you have multiple APIs, if you're doing serverless right, there's multiple access points. So there's a lot of access points that you need to enforce authentication and authorization on. So how do you protect your end user against this inconsistent security hygiene? Because as a good custodian of your end user, you want to make sure that you're not just leaving it up to them. You want to put in some protections to help them. So our recommendation here is that you use Amazon Cognito to authenticate your users. It has some great built-in protections against some standard attacks, like brute force attacks. Out of the box, it has support for multi-factor authentication. And we support both SMS and time-based temporary passwords, so that if you're in intermittent cell phone connectivity, your Google Authenticator code will always work. And then for a less friction experience in authentication with multi-factor authentication, you can enable device tracking, which can be used to suppress that second factor. So if you've used the web browser before, you've used the mobile app before, they don't get prompted again for that multi-factor authentication. If that isn't enough for you, you can enable the advanced security features, and that's really to protect against if an end user's username and password gets compromised somewhere else on the web because that site didn't use best practices, it will prevent you from signing up using that same username and password combination. And it will also, if you try and sign in using a username-password combination that we've seen has been compromised elsewhere, we will send a code to one of their verified email or cell phone numbers so that they can reset their password and update it so that an attacker can't get in. And it also allows you to do risk-based adaptive authentication. So if we see that end user has started logging in from a different geography or is starting to exhibit anomalous behavior in the times they're logging in, it might throw an additional challenge just to make sure that they're not an attacker. So with your long-lived credentials that get compromised, the solution here is really to only use short-lived credentials. So Amazon Cognito, if you use it to authenticate your users, will give you short-lived access tokens by default. These are only good for an hour. So if somebody gets a hold of one of these tokens, they can only get into your backend for an hour, so it kind of limits your blast radius. You should use something like API Gateway to automatically validate these Cognito tokens. It keeps it easier if you're embedding this into your Lambda function itself as the first piece of your Lambda function. It's harder to get right, so you can make mistakes there that let things in that shouldn't be let in. So just it's easier to use the API Gateway Cognito authorizer, so just use it. If you're using API keys with API Gateway, so you have some customers that you're vending keys to so they can call your APIs, we recommend that you periodically rotate those keys. And you can do that with AWS Secrets Manager. You can set something up so that periodically it will rotate those keys and revoke an earlier used key. You might have to come up with some way of communicating with your customer that this key is no longer going to be valid in 2 weeks or something like that. But using Secrets Manager, it allows you to do that rotation. And finally, if you're trying to use IAM credentials directly against Lambda. So if you have some legacy app running on EC2, or you have some need to call Lambda directly, always use either SDS's assume role to get temporary credentials, or use EC2 instance credentials. Those will limit the amount of time that those credentials are good for, so if they get leaked, it's not as big of a problem. So now, with these Lambdas, where you have lots of Lambdas and lots of access points, how do you centralize that authentication and make sure that every single one of your endpoints enforces authentication in the same way? So we recommend that you centralize that authorization enforcement. Like I said in the last slide, use Amazon Cognito authorizers at API Gateway. Or if you're trying to do something more custom, use the Lambda authorizer functionality in API Gateway. So the Lambda authorizer functionality allows you to take a token, inspect it, look at all the claims, maybe based on certain claims that are in that token, you want to build out a custom policy. And so for each one of your end users' tokens, you can build a policy on the fly that gives them access to particular APIs in API Gateway. And API Gateway will cache that policy, and every time you use that token against API Gateway, it won't invoke your Lambda authorizer again. It will use that cache policy and do authorization enforcement there. Alternatively, you can do authentication directly on the application load balancer. And something we just launched earlier this week was direct integration between ALB and Lambdas. Cognito is integrated with ALB, so you can make it so that no request makes it past your load balancer that isn't authenticated. If the end user isn't authenticated, it will redirect to the login. The end user will authenticate, and then it will redirect back into your app. So you can put that on authentication there, and if you have kind of a more simple use case that you don't need to put API Gateway in front of you want to just directly call Lambda, that's a great way of doing it. And my final guidance here is that you don't try and accept multiple token types. You normalize on one token. You don't try and accept like a Facebook token and a Cognito user pools token and some other OpenID Connect token. Like you normalize on the Cognito user pool token. We can federate in from multiple sources, and you just try and implement one. You don't try and implement many, because the less code you have, the more secure it is. let's talk about a quick strategy for how you might centralize authentication and enforce it. So if you're deploying methods on API Gateway, one of the things that you can do is you can turn on CloudTrail. Every time you change a method in API Gateway, it will emit a message through CloudTrail, and you can filter on API Gateway methods to invoke a Lambda function. And in that Lambda function, something that you might do is you might do a describe on that API or just look at what came in through CloudTrail, take a look at the authorizer that's on that method, and if it isn't on there, you just shut down that new method immediately so that before anything bad can happen, it gets shut down. Let's talk about securing your resources now. So the threats with your resources are that if you're not validating your inputs, things like injection attacks can make it through and make it through to your RDS database in the back end. If you have permissive execution roles with Lambda, you might inadvertently, through code bugs, allow somebody to do something that they're not supposed to do. So if you do something like S3 star, you might allow somebody to create a bucket or delete a bucket, and that's something that you don't want them to do. If you hard code secrets, that's just kind of adding friction to your ability to rotate those secrets. You don't know where they are, and makes them harder to rotate, so you probably won't rotate them, and they can get leaked if you upload them to some code repo somewhere. And then there's kind of an aspect of security that often isn't thought up front, and that is kind of the availability of your backend. So if you have misbehaving clients that are utilizing too much resources and browning out your backend, or you are running too many Lambdas concurrently that's just browning out your downstream dependency, that's going to cause your app to be unavailable and kind of be a trust buster for your end users. So I'll talk about some of those threats. And then finally, another threat is if you're using third-party libraries to implement your function, any vulnerabilities that may exist in those libraries. So what can you do about your inputs and to protect against malicious inputs? My recommendation here is that you make no assumptions about any of the inputs coming into your application. Even if you think the input is only coming from code that you wrote from somewhere else, if it's coming through an SQS queue or whatever, you may have code bugs that cause parameters to be missing or null pointers or things like that. Just make no assumptions about where the data came from and validate everything. So filter it, escape any input, and run sanitization on any of that input so it just doesn't get in. If you can, limit your input sizes. So if you only expect files to be under a certain size, limit them to that size. And use prepared statements if you're making calls to RDS and using SQL to protect against SQL injection attacks. And if you want to enable AWS WAF, that's probably something you should do with every single API, because even if you have a code bug or something like that, by having WAF in front, you can, if you detect an attack, you can quickly mitigate it by putting in a filter or blocking those requests. So permissive execution roles, what can you do there? So if the inputs make it by the sanitization that you did in the last slide, but you have an overly permissive role, we recommend that you use this idea of least privilege execution roles. In IAM, we have a bunch of policies for common roles, managed policies. We recommend that you use those wherever possible. If you're rolling your own role, you should probably test it in development first and use something like X-ray in your Lambda function to identify exactly what the permissions this function needs and lock down your execution role to just those permissions. Don't allow S3.star or something like that. If you see star in any execution role, take a step back, take another look at it. It's probably too much. You want to separate your dev account from your production account. So if you don't already have 2 accounts, immediately create another one. Do all your development in one account to silo it off from your production data. Because usually what happens is when you're doing development, something isn't working, you start relaxing permissions, or you do something, you write a code bug and it starts deleting stuff, and you really don't want to affect your production data. So separate your dev from your production and just have completely different accounts. And finally, any roles that you aren't using, you should just go ahead and delete those. The IAM console will show you the last time something was used, so you can reduce your risk when you're deleting stuff. But if you're not using something, don't leave it out there to trap somebody later. Just clean it up. Here's a quick example of how you might do something. Let's say you have a game and you're allowing your end users to kind of track their progress and save their game so that if they transition between devices, they can pick up where they left off. In this example, we're allowing you to update any item in DynamoDB in the table game state. But what if there's some things that you don't want the end user to ever be able to do? You want to do that through some admin backend. So for example, if the user is paid or they've unlocked certain bonuses, if you never want the end user to be able to call a function and manipulate those attributes in your DynamoDB row, you can add a condition to that policy to prevent any access to those attributes. So what can you do to protect against secrets that are long-lived or hard-coded? We always recommend that you store your secrets separately from your code, and you don't use Lambda environment variables for sensitive information. Putting it there makes it harder to rotate, and if it's hard to rotate, you won't rotate it. So always use something like AWS Secrets Manager to store database passwords for RDS. It will help you with the rotation there. And use AWS Systems Manager Parameter Store if you're trying to store configuration. By centralizing it there, it makes it easier to change, and you have more visibility into what configuration you have out there and where things are being used. So if you have clients that are misbehaving, how do you protect against those? We always recommend that you kind of do some sort of load test, and you figure out what's an appropriate timeout for your client. So if you expect this operation to only take 5 seconds and you've set your timeout to 60 seconds, you should just fail fast and retry. And in your retry logic, you should, if you're using the AWS SDKs, it has built-in jitter and exponential backoff so that you don't start some retry storm, that everything is a little bit spaced out. If you want to limit access for your customers who are using an API gateway key to access your API, you can set usage plans on each of those keys. So if you don't want a particular customer to get more than a certain amount of your backend resources or only allow them to do a certain number of requests, you can put usage limits on those keys to block them after a certain amount. If your APIs are heavily cacheable, like there's no reason to redo the request if you don't want to, you can turn on API gateway caching. That's one request that's not going to hit your backend and not put any pressure on your resources. Configure AWS WAF to help you block stuff in a pinch, and always design your APIs to be super low latency. And a good example of this is, let's say that you're uploading a file. Instead of pushing the file to your API and using it to proxy S3, an alternative is to have your client upload the file directly to S3 and then call your API with a reference to that file so that that API only takes a few milliseconds instead of if your client has a slow internet connection, it's holding up open that connection and using that resource for a much longer time. Here's where you can force throttling. It's a quick picture. So you have your website. It's talking through the internet through CloudFront to API gateway, and then to maybe a Lambda function. You can enforce quota metering and throttling using the usage plans in API gateway. And if you put WAF in front of your API gateway, you can also turn on throttling and blocking. So what happens if you set a Lambda concurrency setting that exceeds your downstream capacity? What we recommend to do here is that if latency is not an issue, you just keep your concurrency setting low. So if all of your stuff can back up in an SQS queue, you set your concurrency setting low so you never even have a problem. You should enable auto-scaling wherever possible. So if your requests are hitting DynamoDB, just turn on auto-scaling. Or if we just talked about request-based pricing for DynamoDB, you switch to that if you want something to instantly scale behind the scenes and not have to worry about it. Wherever possible, conduct a load test, find the breaking point of your backend, and use that to kind of determine a lower setting for concurrency so that you're never having requests above the breaking point. And take a look at our documentation on limits for each of the services that you depend on. We have public documentation on all of our limits. If there's something there that you see needs to be increased, request limit increases. So all your Lambda functions typically depend on third-party code, and third-party code occasionally has vulnerabilities. The Open Web Application Security Project is a great resource for tracking these vulnerabilities and providing you dependency checkers that can scan for various runtimes what those vulnerabilities are and to point them out. And if you're depending on third-party libraries, we recommend that you continuously upgrade them, keep them close to the baseline, and that will really reduce your risk and effort if something big comes up and you need to quickly upgrade to a newer library. The closer you are to the baseline, the less risk and effort you have. Let's talk about keeping a paper trail. So the threats with not keeping a paper trail is that you just don't have enough logging. Your application starts throwing errors. You can't figure out what's going on. And then the other threat is that if you have some unauthorized access to a resource, but you just can't see who touched it and figure out what the blast radius is. So with logging, the things that you can do, at a minimum, log who is doing what and any timing information. Usually, if there's some bottleneck somewhere, your application is running slow, if you're trying to debug what's going on, having that latency information is the first piece that you need to figure out what the dependency that's having problems is. Log any basic context to help you with what's going on. So you might log user agent, or you might log what's being changed before and after. Always log request IDs in your clients. By logging request IDs, it really helps if you have to engage anybody from an AWS service. Giving them that request ID and the timing information allows them to quickly look at what happened and get to you easier instead of kind of going through all the logs and trying to find the exact scenario. It will also help you if you're logging the request IDs in your client application, see and trace everything into your API gateway calls and things like that. Wherever possible, enable X-ray in your Lambda functions. That will give you visibility into all the fan out and all the calls to AWS resources and endpoints from your Lambda function. And that's an example of a request ID there. You've probably seen those UUIDs. So if you want to protect against unauthorized access to any of your resources and figure out who did what to all your resources, with your AWS account, never give everybody the same account information. Create individual users in that account or federate your users in. That will ensure that you always know who was accessing your account. Turn on MFA. It's just a simple step that you can take to add protection to your account, and then use CloudTrail. You can turn on CloudTrail data events if you want to see more than just configuration changes, but turn on CloudTrail to see what's happened in your account. So now I'll hand it over to Daniel, and he'll talk about that architecture that he's built at HSBC to monitor and enforce compliance.
Hi, I'm Daniel Lees. I'm the principal technical architect for AWS Cloud Services at HSBC. I'll talk a little bit about our size and why continuous compliance is important to us. So we've got about 4,000 offices around the world. We're in 67 countries. We have $2.5 trillion in assets, and we have 230,000 employees with 38 million customers. Of those 230,000 employees, we have about 44,000 software developers that are part of our organization. So this starts to become a challenge from a technology perspective for us. So we have multiple banking back-end platforms. They're also distributed around the globe, along with our people that are distributed around the globe. And we're in a highly regulated environment. On average, we deal with at least 50 regulators on an ongoing basis, and then those regulators have subgroups, so it spawns up to about 300. And those regulations affect both our applications and how we manage our resources, our technology resources. We also have a rapidly evolving customer expectation, so that's why you see in most of the bank presentations where everybody talks from Capital One to Australia Bank this morning that we have as big of a technology organization as we do in order to facilitate our business applications. So in our AWS estate, this becomes a challenge because we have multiple major business units around the globe. Those business units all have multiple teams developing multiple projects. So when I made this slide, we had 200, but we now have over 300 AWS accounts that are currently active for projects within the bank. We have thousands of developers that are running it, and we're utilizing over 50 of AWS's services already. So as David was going over some of the aspects kind of within a single DevOps pod that you would do for your application protection, if you take one step up and looking at it from an enterprise perspective, we're looking at how we need to enforce compliance for what we have as regulations across our organization at an organization level. So we use AWS organizations to control our account sprawl, and within that, underneath that organizational structure is where we're looking to apply a base level of compliant and standards configurations that we need across all accounts, regardless of what business application you're running. So we developed a continuous compliance framework, and this is kind of a layer above what you might do with AWS Config within your single account. So from here, when we have a business application that wants to use a particular AWS service, we take a look at that service and we define and create the patterns, the security patterns that we need in order to meet our regulatory and standards bodies for that kind of service and what that service may be hosting data-wise. So once we define what those NFRs are, we then design controls to meet those NFRs. So in defining those controls, for us right now in our framework, those are mostly Lambdas across the board, and they may look at a policy, they may look at a configuration, or they may set a configuration and a policy explicitly in account, or they may be a remediated action when they detect something that's present in that account. So we build and implement those, and then we run this on a continuous basis. So there's where we have three kinds of compliance policies that we look at. We have corrective. The corrective ones are the ones where when we see you spin up something that we can't have you spinning up, we will delete it immediately and send you a warning about it, or just you're not allowed to run those without previous authorization, or you need an exemption for the reason that you'd like to run that resource. So like one of the big ones for us is we have extreme requirements on data leakage protection. So in our development environments, normally you do not get the ability to speak to the internet. So we have a corrective control that says, if we see you spin up an internet gateway, we turn the internet gateway back off. You get an email message saying you're not allowed to spin up an internet gateway. If you need to spin up an internet gateway, talk to the appropriate body to get your exemption control on why you would need to spin up that internet gateway. We have detective controls that look for some of the minimum values that we want to see in an environment, as well as to give you warnings when you have something that you've defined in a development environment that may not be suitable for a production environment. So we can depending on how your account is classified for your environment, you can get a different response from our compliance dashboard. And then we have preventative controls that'll prevent you from doing some behaviors that you may not be able to execute. We do use service control policies at the highest level, but that's kind of like a sledgehammer for some of the things. So we take it one level down in our compliance framework, and we use preventative controls at that layer in order to also lock down an environment for some of the requirements that we may have. So what's in some of our controls? So when we're looking through and defining a control set for one of the services or functions from AWS, we have to evaluate what the level of risk is for different areas and where we have to apply some of our compliance controls. So you can see a sample of some of the ones here. Like we have a Lambda. So if you have a Lambda function, assigned IAM roles should be configured with a minimum needed session validity time. So we can check on that, and we can warn if the validity time was outside of a standard that we're looking to have on that application. Security groups on your VPCs, we can see whether or not you have any open security groups, and we'll flag you for open security groups, or if you're using ports that we would normally define as a suspicious port that we want to have turned off, or just give you a warning that you have ports that are out of the standard. Or even things where like the framework itself actually has the policies and the controls to make sure that it can still query your account and it can do the things that it needs to do. So this compliance framework that we have generates a dashboard, and that dashboard will have the result of the queries of all those compliance functions against the different accounts. So in that dashboard, we have a RAG status, red, amber, green. Depending upon your environment type and what kind of exceptions you have is how you end up getting rated. You might have red if we find that you're running an old AMI and you have not refreshed your AMI, or you might get red if we find that you have a permissive S3 bucket. When you shouldn't have a permissive S3 bucket. There's been a couple things that have come out recently that we can start to shrink some of the things that we were doing, like we can turn off public buckets by default now. That's really helpful. So some of those things will start to reduce the number of controls that we had developed ourselves earlier on, because we've been running this for about a year and a half as far as maintaining the compliance standards. And then so we will send out both this dashboard that folks can come on and get a view, and we also have a weekly email that will come along for the overall status of your environment. So as the owner of your account, you'll get an email as the compliance framework is run against your account. Or if you're a red account, you may get an immediate alert based off of an email or a text for a red account violation that's been flagged within your account. So if we want to think a little bit about how that flow works, these are the functions that we use to do that. So the tools that he was talking about in protecting an individual account, we actually execute some of those tools for our framework's access in order to evaluate all of our accounts across the board. So we use the STS assume role for our Lambda function that's in our centralized compliance account. And from that point on, we have the policies that allow that Lambda function to query what we need to query, or to temporarily assume the role permissions that it needs in order to execute an action in that account. In those individual accounts, the one thing that we're doing is we're consolidating CloudWatch and CloudTrail events to the CloudWatch event bus. So any actions that occur within those solution accounts all go into the event bus, and they're consolidated. All those events from all the accounts are consolidated into our compliance account. The Lambda functions that are in our compliance account are watching that cloud events bus for all those events, and anytime any event comes through, evaluates it against the rules that we have in that cloud event bus. We have a database there that stores exemptions for different accounts, so we can see an account ID, they may have an exemption that they're allowed to run an internet gateway, or I'm not sure why somebody would still do it, but they may have an exemption for an IAM user rather than a role. So there's those kinds of things we may have a few exemptions for within an account. And then depending upon whether or not that exemption clears through there, or if it's one of the alerts, is what that action is going to be after. If it's a corrective action, then that Lambda will assume a temporary trust token in order to go on that solution account and deactivate that service or change that parameter into what is an acceptable value, or it'll just generate a detective alert that'll add to the dashboard. It may send you an email. Or it also will just keep consistently looking for our baseline configuration for our base NFRs that we need across those accounts from a security perspective. You can do a lot of these things in a smaller account level with AWS Config, and I'd probably say that would be the way to do it. But when you start to have 300 accounts, AWS Config gets a little unwieldy as far as managing the assets for the rules within there. And that's why we came up with our compliance dashboard. One of the things that came out this week was
Control Tower.
Control Tower, yeah. So if you have a few accounts, Control Tower will probably still end up working out really well for you, because you can consolidate your config views in Control Tower. The difference is for our compliance account is that we wanted to centralize the compliance controls into one area rather than have to deploy them out into all the accounts. So that was one of the reasons we built this system, and then used cross-account assume role trust for branching out to do our queries and our corrective behaviors. I don't know if you want to add some closing comments.
Yeah, so if that was interesting, what Daniel did, if you want to see our managed solution so that you have to write less code and get all this goodness, take a look at that AWS Control Tower.
One question I had from our last session that I'll add up now is we have about 58 controls in there. So each of those controls is Lambda itself, but we run those 58 controls individually across 15 regions. And we probably see about 350,000 events a day right now coming through our compliance framework that we're evaluating those Lambda controls against.
I'd like to really thank you for coming out today. I know that the expo is now closed, so we're going to step down off the stage. If you have any questions about Amazon Cognito or any of the things that we talked about today or more, you want to hear about more from Daniel about his architecture, we're going to step down and you can ask us those questions off stage. And we really appreciate it if you could provide feedback in the mobile app. That's how we figure out what to do next and what you guys want to hear. So give us that feedback. And thank you again for coming out.
Thank you.